What is the Reynolds number? Oh shoot, did anyone write down the formula we just had on the key concept slide? Let me see. I think it was, I was just looking at it, so it was N sub R. And for the pipe situation, it was 2 rho VR over that Greek letter eta for viscosity. And so that could be an answer. There it is. There's the formula. Is there anything more to it than that? Looking at the answer here on the slide, it mentions that it is a dimensionless number that can qualitatively predict whether fluid flow will be laminar or turbulent. And so it's interesting. Yeah, it is a dimension. It's just a pure number, right? So in that sense, when we looked at the 2000 and the 4000 cutoffs that we're going to usually work with, there were no units attached to that. So maybe if we looked at this, and I'm just going to look at this and thinking, does that V look sufficiently different from the R there? This one right here. Okay, I'm trying to make that more like a V so it's distinguishable from the R. But I think if we went through all the units here, you remember the units for viscosity, that was like pressure times time, right? Pascal seconds, that's the weird one. The other ones we could probably figure out. So maybe I'll leave that to you. If you want to try that out and say, okay, let's look at all these units and really see that it is unitless. So as long as you make sure that you're using, like, if you're not mixing different types of units in these quantities, they should all just cancel out and it should be a pure number.